All right. It's a beautiful evening right here, and I welcome everyone to tonight's class. Uh, I really hope that we're able to cover much with perfect understanding of more aspects around calculus. So tonight we will be getting into a different phase of calculus. Last week we dealt with domain and range. We also went through the theory around continuity and discontinuity. And we also talked about limits, and we spent some time on L'Hopital rule while dealing with calculus. Now, in tonight's class, we want to start with another aspect of calculus, which is differentiation. Now, I'm sure we all have the general ideas around differentiation already. The general differential tactics is for you to always, let me say it this way, if you have y equals to x raised to power n, let's take this as any function, linear function y being equals to x over n. If you are told to find dy over dx, which is what we say is differentiation. If you are told to do this, what you have to do is to, this is the general principle around differentiation, is you multiply the coefficient here, the power here by the coefficient here. Now, for this general y being equals to x over n, the coefficient here is 1, so that will be 1 times n, and then you would have x raised to power, you subtract 1 from the power. So that's n minus 1. So generally, when differentiating x raised to power n, we have nx raised to power n minus 1. This goes for any type of expression. Y equals to, for instance, x squared. This would be 2x, that's 2 times the coefficient 1, raised to power 1, because this would be 2 minus 1. Let's say, for instance, we have y being equals to 3x4. In this case now, you will say 4 times 3, that will be 12. Then you write the x, then you subtract 1 from the power, 3. Let's take one more. Imagine we have y equals to 10x raised to power 2. You multiply the coefficient with the power, that will be 20x raised to power 1. That will be 20x. So this is the general rule around differentiation, which I believe many of us are already familiar with. Now, but in your exams coming up, sometimes there is another way of doing all these things, and we call it the first principle, the differentiating according to the first principle. So that's what we want to spend more time with today. So we want to be using the first principle to do differentiation. Now, let me say this before we start doing this. If you are given a question and you are told to make use of first principle to differentiate that expression, you must not use the general principle that I just did. So imagine you're given y equals to x squared, for instance. Now, obviously, you can easily run through that and just write y equals to 2x. But you see, this is what I'm saying. Imagine you have y equals to x squared. Now, it's so easy to differentiate this and say dy over dx equals to 2x, and you are done. Just 2 lines. Now, but if you're told to make use of first principle to do the differentiation, you are not permitted to do this. You must go through the whole step according to the first principle. So that's what we want to spend time with today, and we'll see how far we're able to go with it. Now, I want to tell you that, just as in every aspect of mathematics, we always have the basic aspect, the basic question, which is always best for us to start from that place. And then we move on to much more complex aspect of it. So we'll be starting with the basic aspect of applying first principle, and then we'll go on to solve questions. Actually, we're going to do questions around circular function using first principle, which I'm sure those are the kind of questions you would be majorly asked questions on, because when you have an exam like A-level, they want to ask you to use first principle to differentiate y being equals to cos x, and they say you must use first principle. So those are the kind of things you want to practice perfectly. So let's see how we go from here. So what are the rules? What is the rule around first principle? We have 4 rules that must be followed. Once you see, it's quite very simple, very, very simple. Everybody here can do it if you pay real attention. And we're going to be very, we're going to move step by step so that everyone can follow us. So let's see. What is the 4? We have 4 steps. I'll be talking about 4 different steps for first principle. Now, the very first step, and please let me stress this, just like I explained to you while doing inverse of a function, you always have to follow these steps the way they are. The very first thing you want to do is to increase each variable. Increase, you put an increment, increase each variable. Let me give an instance now. Let's say we have y being equals to x squared. What do I mean by add an increment to each variable? This is the increment. You had y before. You want to add an increment. So the increment will be what we call the change in y. So this is the increment right here. This, the y. This is the incremental aspect of y. So it's like you are adding an increment of y to y. That's what we're talking about here. So you increase each variable. The same thing goes for x. You increase x to x plus the x. Then this is the way you do it. You have to increase each variable. I'm trying to be as layman-ish as possible so that everybody can flow with us. You don't want to, we don't want to use so many terminologies here. Let's just move in such a way that everyone can easily follow us. Now you want to increase each variable. So when you have, wherever you have y, whatever kind of question, let's say we had, for instance, y equals to cos x, for instance. Of course, if I had y equals to cos x, let's say we had y equals to cos x, how do we solve this? The same thing. You go on to increase y, that will be y plus change in y equals to cos x plus change in x. That's the way you do it. So you can see what we are doing right here. Any question you have, let's take, for instance, you are trying to differentiate y equals to 1 over x. The same thing flow here. What you want to do is to do y plus change in y will be equals to 1 over x plus change in x. Then see how we're doing it. Wherever we see x, we increase it by adding the change in x. Wherever we see y, we increase it by adding the change in y. So that's the first step you must always follow. What is step number 2? Step number 2 is that you have to now divide each side. Of course, you have to divide, you have to make, before you divide, you have to make the change in y the subject of formula. Now, look at these 3 examples I've given. This is the first, this is the second, this is the third. We have successfully added an increment to this. We have added an increment to this. We have added an increment to this. So the next step would be to make the y subject of formula. Make the y the subject of formula. This means, of course, according to the principle of mathematics, you want to go on to find a way to isolate the y. Sorry, change in y. You want to isolate change in y and put every other variable on the other side. Same thing goes here. You want to isolate change in y. You want to make change in y the subject of formula. And this one also, you want to make change in y the subject of formula. So that is the principle around first principle. That's the second step. The third step will be for you to now divide. After making change in y the subject of formula, then you want to divide. Let's take, for instance, you have change in y being equals to let me use this 1 over x plus dx minus y. Of course, this will be 1 over x. Just imagine this was what we had. So what I want to do next now is to divide both sides. That means the left-hand side and the right-hand side, you want to divide through with change in x. So you want to divide through with change in x. That's step number 3. You want to do, after making the y subject of formula, then you divide both sides by change in x. All right. And the last but not the least is that you want to take the limits of both sides with change in x tending to 0. You want to take the limit of both sides. So after making the x the subject of formula, then you will take the limit of both sides and you will subject the x to 0. The x will be tending to 0. So this is the basic principle around the first principle. All right. Now, these 4 different steps are very vital to follow step by step. And we're going to start from, as I said already, the basic. We're going to start from a very basic example, and then we'll move on to solving more complex questions. All right. Now, let's take the very first example, which is the simplest one. We have y being equals to x squared. Now, ideally, if you are dealing with if you're asked to just differentiate this, you would say the y over the x will be equals to 2x, and that's all. So this is the answer we must get while we're done with first principle, using first principle, because by following the general rule, this is the differentiation of y with respect to x. This is it. But let's make use of first principle. How do we make use of first principle? The first step I told you was to put an increment to both sides. So that means we want to have y plus change in y will be equals to x plus change in x all square. All right. And that's step number 1. We have done that successfully. What is step number 2? Step number 2 is you want to make the change in y the subject of formula. So we want to find a way to make the y subject of formula. Of course, this is easy. All you have to do is to put this y, you want to turn this y to this side. So you have minus y, because you turn this to this other side. Then you have minus y. Now, if you observe carefully, you will see that y is equals to x squared. So our change in y, is x plus change in x all square minus y was equals to x squared. So we can go on to write since y equals to x squared. So we're going to be substituting y for x squared. All right. Now, this is what we have now. And we can now go on to try to simplify all this. And we have done 2 steps now. We have 2 more steps to go. But before we go on to the 3rd step, let's try and simplify what we have right here. So our change in y will be equals to x squared. Of course, I have taught you already how to open functions like this. You don't want to be putting aside. You can easily do this by saying x raised to the power 2 plus then 2 times x times dx. That will be 2x dx. Then plus x squared, then minus x squared. All right. So this is good, but we can see something is happening right here. There's x squared here. There's x squared here. So obviously, these 2 can cancel each other. This will cancel this, and we are left with the y being equals to 2x dx plus dx all square. So we have done step number 1. This was step number 1. This is step number 2. We have made the y subject of formula. We have simplified. All right. Now we want to go on now to do step number 3. What is step number 3? You want to divide both sides by changing x. So step 3 now will be for you to have the change in y over change in x, and then you do for both sides. So this will be 2x, change in x plus change in x squared. We divide through by change in x. That's step number 3. All right, step number 3. Now, when you look at this step number 3, you can see that, of course, I expect you to understand that this can be splitted, and what this will obviously give you is that you'll be having this to be 2x, because the change in x here will be cancelling the change in x here, and we'll be cancelling one of these. So obviously, you'll be left with, I'm sure you understand that aspect of things. I don't want to spend more time on that. So this is going to be the final answer, because the x is found there. So if you isolate this, if you make this, in case for those of you that are interested in knowing, you can split this as this, obviously. So then from there we can get here. So this will cancel this, and this will cancel one of these. That's how we arrived here. So at this point now, we have the third step being finalized. So we have done step 1, step 2, step 3. Now we have the last step. And the last step is for you to take the limit of both sides. So you want to take the limit with change in x tending to 0, the y over the x being equals to, of course, you take the limit of this side also, and then you have 2x plus the x. That's step number 3. I told you the key to understanding anything in mathematics is follow the steps. So we have done step number 1, we have done step number 2, step number 3, step number 4. Now we're taking the limit of both sides with change in x tending to 0. Now, I want to submit to you that wherever you see this, what you have here, wherever you see this, what you have here, anywhere in mathematics, this is the same for the y over the x. That thing I wrote here is the same thing as this, the y over the x. So this means invariably that we have been able to, because don't forget, we're trying to differentiate using first principle, and we're trying to differentiate y equals to x squared. So that means I can easily write this whole thing as, of course, we are on step 4 now. The y over the x will be equal to, now let's see what the limit of this will give us. Obviously, I'm sure you guys are very familiar with limits already. So when I have the limit of change in x tending to 0, I have to fix in 0 wherever I see my change in x. If I do that, I'll be having 2x plus 0. And then I can finally write my answer as the y over the x equals to 2x. Can you see that this gave us the very same answer when we followed the general principle? All right. So that's how simple this is. Of course, I told you this was a simple one. We can go now into deeper one. So I want you guys to now pick up your pen now. We're solving together while I'll be giving you questions, and then you'll be applying the first principles to it as we normally do. So, and you're going to be submitting your answers in the chat box. All right. So let's start with y being equals to 3x squared. Of course, we can make use of the fast way, but if you make use of the fast way here now, I'm sure you know we're going to be getting our answer in seconds. So if you're going to use first principle to do this, we're going to be having the y over the x to be equals to 6x raised to power 1, which is 6x. Right? Now, but we have to use first principle. So what do we do here? Can you start this, and let's see how we go from here. So start this wherever you are, so that you will have the opportunity of of making mistakes and also correcting yourself. So we have y being equals to 3x squared. All right, we want to use first principle. Step number one, put an increment to both sides. So we have y plus change in y will be equals to 3. Wherever we see x now, we are incrementing it, x plus change in x all square. You can see the principle. Wherever we see y, we increment it with change in y. Wherever we see x, we increment it with change in x. We follow the same. We are not going to change anything other than that. That's step number one being done. Step number two is for us to make change in y the subject of formula. So we want to make change in y the subject of formula. So of course, this will be 3x plus the x squared minus y. All right, you can see it right there, 3x plus the x squared minus y. We have been able to make the y subject of formula. So what you want to do now is, of course, since y is equals to 3x squared, that means I can have my change in y being equals to 3x plus the x squared minus no longer y now because y is 3, so I'll write 3x squared. Now, I can still go on to simplify further, and I can open this as 3 into bracket. We have x squared plus 2 plus 2x dx plus the x squared, then minus 3x squared. Can you see the way I use my bracket very perfectly? That's to ensure I don't make any errors. 3x squared plus 6x dx. I'm opening the bracket right here, plus 3 the x squared minus 3x squared. Now this is my change in y. Now I've been able to make change in y the subject of formula. So what do I do next? Step number 3 said I should divide both sides with change in x. So I have to go on to divide both sides with change in x. All right. So I want to divide all this with change in x. So let's see what we're going to have. Of course, everything we're dividing with change in x. So this obviously will give me something of this sort. I will have 3x squared over change in x plus 6x change in x over change in x plus 3 change in x squared over change in x minus 3x squared over change in x. All right. So some will be able to cancel while some will not be able to cancel. Of course, this can cancel this. This will cancel this. Will be left with just 1. This cannot cancel. All right. And the next thing to do right here now is the next step is for you to take the limit of both sides. So all this will, if you take the limit, I told you already that when taking the limit of this, the limit of change in y over change in x, the x tending to 0, then I take the limit of every of this, the x tending to 0. So I have 3x squared over the x plus 6x plus 3 dx minus 3x squared over the x. All right. One thing you can see right here is we will be having it looks like, okay, so we'll be having all this turning to zeros because all this goes away. We'll be left with just 6x. If you fix in 0 there, everything all will be eliminated except for 6x. You can see it right there. Put 0 into all those places for the x. I told you already that this will obviously convert to the y over the x will be equals to, so when you do the limit of all this with the x tending to 0, you can notice that this is the only place where you do not have the x. So this will have to be your final answer. So that's the way you go step by step right now. How many of you was able to arrive at this answer while dealing with the first principle? Again, as I said already, it's step by step. We'll get into expressions now that some of you may find it much difficult, but of course, I can see that all these are still very simple. So let me do probably the last of this kind before we go into a different kind. And I would love you to solve also. So the last of this kind so that we can at least establish the point you have been making. So we have y being equals to x cubed. Y being equals to x cubed. Can you make an attempt on this using first principle? You'll have to use first principle. Of course, using the general principle, we know that in this case, the y over the x will be equals to 3x squared. Right? That goes without saying. 3x squared. Now, how do we go on to solve this? Please, can you start doing this? I don't want you to just follow through on my own workings. I would love you to attempt this also. Can you try attempting this without using the general principle? Make use of the first principle. Let's try and solve this. Do yours while I'm doing mine. So we have y being equals to x cubed. Now, we've already gotten the answer for the general principle, but for the first principle, we have 4 major steps we must walk through by. The first is for us to increase our both the y and x variable. So this is me increasing it, y plus change in y equals to x plus change in x, everything raised to power 3. All right, that's the first thing. That's the very first step. Now, the next step is for us to make the y subject of formula. So we have change in y. We want to make change in y rather subject of formula, which will be equals to x plus the x raised to power 3 minus y. Do you see this? I just take the y to the other side. Now, what do I want to do next? Before I do the third step, I want to try and simplify this. Now, I know that y was equals to x cubed. Since y was equals to x cubed, I can go on to write change in y is equals to x plus change in x all cubed minus now x cubed. All right. Now, I can go on to still simplify this. Now, to simplify this expression, one of the things you can always do is to try and express, of course, x plus the x cubed, because you may be in the exam hall and you have a question like this. The faster way to do this is just to have x plus the x, then x plus the x squared. Of course, there are identities you can use, but I know many of you will not be able to cram that. So let's just walk through the most visible way for you. So in this case now, you can expand this as x squared plus 2x dx plus the x squared. I think I will just leave this for you to do. I will not perfect this. Then you go on to say x plus the x. So go on to then expand this, you get your final answer. So, but just for the sake of time, I would be giving you the answer to this. So when you expand this, what you're going to get, the y will be equals to x cubed plus 3x squared dx plus 3x dx squared, then plus the x cubed. So this is the expansion for this right here. And don't forget there is a minus x cubed. So this will be minus x cubed. All right. So looking at this, you can obviously see that the x cubed here will cancel the x cubed here. That's by default. X cubed minus x cubed will be 0. So that goes out. Now, you're left with this. This is what you're left with. The y being equals to 3x squared dx plus 3x dx squared plus dx cubed. So what you want to do now, third step, the third step, now we have done first, second step, we want to do the third step. The third step is for us to divide this expression with the x. The y over the x will be equals to all this over dx. So we have 3x squared dx over the x plus 3x the x square over the x plus the x cube over the x. So you can obviously see this step by step. You can never go wrong. Just move step by step. This will cancel this. This will cancel one of this. This will cancel this. You'll be left with two of this. All right. So that means you are left with the y over the x. I understand this is still basic, but this is the way to go about learning. You want to start with the basic one before you go into, sorry, just one of this is left, before you go into a much complex one. Once you are done with the basics, the complex ones will be quite easier. Now, the next thing you want to do now, we are done with the third step. We want to go on with the last step, which is the fourth step. Fourth step, and you are done with the question. The last step is for you to take the limit of the x tending to 0, all right, of both sides. So we have the y over the x here will be equals to, of course, the limit of all this. The x tending to 0, sorry, changing the x tending to 0, 3x squared plus 3x dx plus the x all square. All right. So if you fix in the x as 0 here, one of the things you are going to see is that you're going to be having this will go, because this will be 0. I don't think we need to always write that. I'm sure you guys can. This will be, what we'll be having will be, of course, this whole thing here, this whole thing right here is what we'll be having as dy. So don't ask that, where is our differentiation? What we have here, taking the limit of changing y over changing x with changing x tending to 0 is equivalent to differentiating. This is it, dy over the x. So we have this equals to, now if you fix in the x of course, taking the limit of the x tending to 0, this will be 3x squared. This will be plus 3x 0, then plus 0 squared. So this will be the y over the x will be equals to 3x squared. Do you see? And you see the reason why the exam, you see the steps we had to take. We have arrived at the same answer we arrived when we started. This is the reason why this kind of questions comes out a lot, where they will say using first principle. So when they say using first principle, they do not expect you to make use of any other method. Of course, you can use the general principle as a guide, but you don't have to write that as your solution, because it will not be marked for you. So you have to learn these 4 different steps, applying it to any question you're dealing with. So I'm sure you are able to flow with that. So let's go into a different aspect now, so that you can grow in the use of first principle. So we have solved, of course, I told you already, we'll be using first principle for questions that even has to do with secular functions. But now we have been able to establish ourselves in these major ones. Now let's go to solve this. Can you try this? Y being equals to 1 over 2x plus 3. So can you solve this now? Now these are places where you need to pay real attention, because these are much more technical than the previous ones we've been doing. So can you solve this? Can you put your hand to work? Follow the same step and try and solve what we have in front of us. Follow just the same step. How do you solve this? What is the solution to this? Just start to solve this. Anybody there got an answer? Now, by the way, let me try and, I told you it's always good practice for you to make use of the general principle, so that when you are done with your answer, you can easily compare them. So if you're going to solve this using the general principle, I'm sure you can solve this using the general principle. What you will have to do is to take y being equals to 2x plus 3. Look at it. 2x plus 3 raised to power minus 1. Can you see this? This is the way you'll be able to know what to do. Now, you cannot solve differentiating this without doing this is almost not possible. So, but I'm sure you understand that what I wrote here is the same thing as what I wrote here. So in this case now since you have a compound function inside here, it's not just, imagine it was, for instance, let's say it was 2x raised to power minus 1. If it was just something like this, you could easily use the general function and say minus 1, 2x raised to power minus 1 minus 1. But you know, you have a complex expression here, a compound expression. It's not straight up. So you cannot just go on to say minus 1 times this and say 2x plus 3 raised to power minus 1 minus 1. That will not work here. All right. So don't make that mistake. When you're dealing with compound expression raised to power something, you have to use what we call the chain rule. All right. We have to use what is called the chain rule. So that's not what we're doing today. We're not talking about the chain rule or any other rule, but I'm just saying in case you wanted to use the general principle, that's what you will have to do to get your answer. You have to use the chain rule here and get an answer. So you use the chain rule and you got an answer, then can you come forward now to solve it using first principle and see if you're going to get the same answer? So let's try and solve this using first principle and let's see what we're going to get. All right. Now, first principle. What is see, when you have, no matter how complex the question is, just follow it step by step. That's what matters. All right. The first step said increase both the x and y variable. So change y plus change in y. That's it. It's the same thing. Will be equals to 1 over 2. Wherever you see x now, put in x plus change in x plus 3. Can you see the first step? It's quite just basic. Follow the steps, you don't go wrong. All right. Now look at what we have here. The next thing is for us to make change in y the subject of formula. It's the same principle. Make change in y subject of formula. So change in y will be equals to, of course, 1 over 2x plus the x plus 3 now minus y. Now, but I'm sure you understand that since y is equals to what? Y is equals to 1 over 2x plus 3. So obviously, you want to say the y now is equals to 1 over 2x plus the x plus 3 minus 1 over 2x plus 3. That means I'm fixing in my y now as 2x plus 3. Please, can I get feedback? Are you guys flowing with me? Are you being able to understand what I'm teaching? Hope you're not lost. Hope nobody is lost in this class. I want to be sure that, are you flowing? Are you really understanding what we're doing? All right. If you want to drop your names now, you can start dropping your names. Can you please identify that you understand what I'm saying? No, I hope is there anybody here that is not understanding the first principle? Is there anybody that is lost in this class? Okay. Now I love that. Okay, you are flowing. I love to hear that. Okay, that's good to know. So if you see a question like this, what you want to do is to follow the same thing. So I've done step 1 by increasing y and increasing x. Now I've done step 2 by changing y the subject of formula. This is it right here. The last thing I've done. So now the next thing I want to do is to try and simplify this as much as I can. Which the only thing that, I told you that in cases like this, it looks more complex. All right, it looks more complex because it was not as direct as the previous ones we have been doing. So when you have a question like this, again, don't panic. Just follow the right procedure. So what's the right procedure here now? We have change in y. We have this other thing by the right hand side. This is a fraction. This is a fraction. There's something in mathematics that helps us to deal with fraction the right way. What do you want to do now? You want to get the LCM of both of this right hand side. And if you want to get the LCM of a complex expression like this, you don't have, if it's 9 and 12, you can find the LCM as 12 and all those many things. But in this case, all you have to do is to just link both denominator together like this. So you have it as this. This is the left denominator. Look at it. I put the left denominator here. This is the right denominator. I put it here also. Simple. So that's the way you go about things. No, you don't have to panic at all. Just follow the right procedure. So what you want to do next is to say this denominator goes in this whole thing. Of course, you'll be left with this because this will go here. It will be left with this. So this times the numerator 1. That will be 2x plus 3. All right. I'm sure you can see that. That's the first thing. Then minus this one will go in this whole thing. Of course, this will left with this. This times 1, that will be 2 into x plus the x plus 3. That's all I've done now was just to take the LCM of both sides. All right. I just took the LCM, nothing more. So, and the only thing I did is that I took it carefully. So let me try and solve the numerator. I have 2x plus 3. I want to open the whole bracket now. I don't want the brackets to be there. So this will be minus, let me first put this bracket and make it 2x plus the plus, sorry, 2x plus 2dx, then plus 3. Then everything will be over. Let me just write the denominator. I don't want to have to be writing. You understand what I mean? This is what I mean by denominator. Just leave it as that. Now, let's go on now to try and simplify that numerator further. So I have the y equals to, I have 2x plus 3. Now I want to open that whole bracket. I have minus 2x minus 2 the x minus 3. And everything over the denominator. Let me still write it as denominator, please. I don't want to just have to. So now look at what we have here. What we have here now, we have 2x minus 2x. This is 2x, this is minus 2x. So 2x minus 2x, these two will cancel each other. I can see 3 and minus 3 here. These 3 will cancel each other. And you see how much we decongest the numerator very quickly. All right. So we have minus 2dx over, then we have 2x plus dx plus 3. I'm writing the denominator in full now. And we have 2x plus 3. Can you see how we have been able to simplify the complex denominator? So that's what makes questions like this a bit complex, is that the expressions you'll be getting will require patience and technicality to make them work. So look at what we have now. We are done with making the y subject of formula. The y is the subject of formula already. We have done step 1, we have done step 2. Now we have to go on and now do step 3. What is step 3? Step 3 is for us to divide the y over the x, both sides. You divide both sides by changing x rather. So I have all this. This is minus 2. Permit me to do something. Of course, it's not, I'm not doing anything wrong. I just love to keep the work neat. And I don't want to be, I'll tell you what I want to do now. X plus, okay, sorry, 2x plus 3. Now, normally, I divided this one by dx. If you are not very good in understanding, some of you want to write over dx again. But I don't need to do that. I can just easily use this sign here. I can use it like this and just say divided by dx. Because that's me saying I've divided the x here, the y over the x here. I'm dividing this whole thing by the x. That's what I'm saying. So instead of me writing over the x, I just did it this way. And obviously, this will turn out to be, I'm sure you know, if I change it to times, this will change to 1 over change in hex. All right. Can you see the process? The process is quite simple. Now, looking at this already, I'm sure you can see clearly that there is a dx here. Sorry, there's a change in x here. We'll cancel this other one. So we're left with this. We're left with we're left with change in y over change in x being equals to minus 2 over 2x plus change in x plus 3. 2x plus 3 times 1 is the same thing. So this is what we're left with. Is it blur? What's making it blur? I don't get. I don't get. Is it blur? I'm not seeing the reason why it should be blur. Is everybody having the same experience, or is it clear on any side there? So Can we move on? Okay. Can we move on? Are you getting it? Are you seeing it clearly? Are you seeing it clearly? Or is it just that person? Okay, it's now clear. Okay. Okay, it's no longer blurry anymore. Okay, that's okay. All right. Now look at it now. We have gotten this is the third step. I told you I want this thing to be, I want you to understand this thing step by step, not just rushing things up. Just follow the right step. We've done step number one. We increased both x and y and x. Step number two, we made the change in y, the solid of formula. Step number three, now we have divided through with change in hex. Now, step number four, which is the last step, is for us to take the limit of both sides while the x is tending to 0. So we have change in y over change in x being equals to the limit of this other side with change in x tending to 0. We have minus 2 over 2 into x plus the x plus 3, then 2x plus 3. All right. So you can see how easy this thing is. I've told you already, these are questions that do come out, and they will not tell you to use just any formula. They will ask you to use first principle. It's a very examinable aspect of calculus, very, very examinable. So you need to know how to flow with the steps. Now look at what we have here. I told you already, don't whenever you get to a point where you have change in y over change in x, and you're taking the limit of change in x tending to 0, understand fully that that implies you having the y over the x. This is not, I don't want to spend time explaining all these nomenclatures. We can go into that if you want to, but for this class, I want to just ensure that you understand the principles around all these things. Now, changing the y over the x now, which is what we're told to do. We wanted to differentiate the function. We have been able to arrive here now. Now, we want to take the limit of this side now. That means wherever you see the x, you want to put 0 right there. So let's do that. Minus 2 over, we have 2 into bracket, x plus 0 plus 3, and we have 2x plus 3. This will be minus 2 over, this will be 2x plus 3, and this will be 2x plus 3. Who is seeing what I'm seeing there? The meaning of 2x plus 3 on this side, 2x plus 3 on this side. That means I can take my final answer to be what? My final answer will obviously be minus 2 over 2x plus 3 square. Are you seeing that? So this is it. Now, I want us to do something quickly because I'm not sure I will be having a separate class for chain rule. So I want us to, can you see the answer we got now? We have used first principle, we got this, right? Can we do something quickly? Can we make use of chain rule now to solve the same question so that at least we are able to balance things up? Let's try and use chain rule to solve this question now without using first principle. Let's do that so that we won't have to have any separate class on chain rule. We'll just move on with every other aspect. So let's use chain rule. We have, I told you this is equivalent to y being equals to 2x plus 3 raised to power what? Minus 1. Now, what is chain rule? Chain rule is more like you would say, take y equals to u raised to power minus 1. That means you said, the meaning of this is that you said u was equals to 2x. You took u as 2x plus 3. Now, you took u as 2x plus 3. So that means you have been able to represent y being equals to u raised to power minus 1. That's just nomenclature. You can put any other alphabet there if you are going to just follow the right steps. So because I saw this is a compound expression, I don't want to, I know this is not so perfect, so I just put it as an alphabet. I say let u be this. Okay, so that means u is equals to y equals to u raised to power minus 1. But now that u there was a compound expression. So if you want to use, if you cannot just go on to just use the general rule, you will have to use chain rule. Now, how do you use chain rule? Look at it, please. Chain rule states that if you have something like this, what you have here, the y over the x will be equals to the y over the u dot, that's times the u over the x. This is chain rule. Look at it. The y over the x is equals to the y over the u dot the u over the x. It's quite easy to understand the flow because it's almost like saying the y over the u over the x. It's more like the u cancels the u, the y over the x. That's just an easy way to remember it. Of course, that's not what it means, so, but that's just an easy way to remember it. So now, this means that we try to find the differentiation of y with respect to x is for us to go on to differentiate y with respect to u. You know, if you used p instead of u, wherever you see u here, you have put p there. That's just me. If you used z instead of u, you will put in z wherever you are putting u here. So that means for us to differentiate this compound expression, what we have to do is say the y over the u. That will be u differentiating this one. The y over the u now, let's try and do it. The y over the u will be what? The y over the u will be equals to minus 1. Look at it right here. You want to differentiate this normally. Minus 1, that's minus 1 times the coefficient of whatever you're dealing with here. That's 1. Minus 1 times 1 is minus 1. And you have u raised to power minus 1 minus 1. That's the general principle of differentiation. This will be minus 1 times u raised to power minus 2. That will be minus u raised to power minus 2. This is the y over the u. This is just applying the general principle. All right. Now, the next thing you are looking for here is the u over the x. You already have u here as 2x plus 3. You want to differentiate u. You know, the meaning of the y over the u meant you were differentiating y with respect to u. That's it right here. That's what we did. Now you want to differentiate u because this is the u over the x. You want to differentiate u with respect to x. So the u over the x will be 2 because if you are trying to differentiate with respect to x, I'm sure you know that you differentiate each of them individually. This will be 2x. Differentiating 2x is the same thing as 2. I'm sure you know that. That's 2x. If anybody flowed with me, I'm sure you all understand that, don't you? Now look at it. We have the u over the x is 2, and we have gotten the y over the u as minus u. That means the y over the x will be equals to minus u minus 2 multiplied by 2. All right. So at this point now, you can go on to feel that means we are having minus 2 u raised to power minus 2. That's just the meaning of this. So now that we have this, we can put in our u as 2x minus 3. Sorry, 2x plus 3 raised to power minus 2. So you'll be asking me that how, of course, this is the final answer, but you'll be asking me how does this correlate to this? Yes, it does. If you want to put this much better than this, you can have this as minus 2 multiplied by, of course, you know this is the same thing as 1 over 2x plus 3 raised to power 2. That's the meaning of this, which is still the same thing as minus 2 times 1. That's minus 2 over 2x plus 3 square, which you can see aligns the same way as we did. So this is great. Can you see how we're able to use chain rule? We arrived at the same answer. We're using first principle, we're getting the same answer. That's how it's supposed to be. Whichever way you follow, you must still arrive at the very same answer. But quickly, let me answer the question on the heart of some people. How do you know what rules you have to use? How do you know you're supposed to use chain rule? You use chain rule when you have a situation like this, when you have it doesn't have to be minus 1. It could be anything. It could be once you have maybe 3x minus 1 raised to power 1 over 2, for instance, or raised to power 3, or raised to power minus 5. Once you have a situation like this, where something is raised to the power of something, positive or negative, but that thing is a compound expression. It's a compound expression. It's in this situation, like it is in situations like this, that we make use of chain rule. So you need to understand that, so that whenever you come across expressions, because very soon we'll be dealing with complex expressions in which you may use chain rule, use product rule, use different things all in one question. So you need to understand when and how to make use of this expression. So let's solve something else using first principle, and let's see how it goes. Now, let me see you try this. Let me see you try this. Of course, you're supposed to use first principle. First principle, all right? You're supposed to use first principle. Let me see you try this. Y is equals to 1 minus x over 1 plus x. Can you try this using first principle? Try this using first principle and let's see how it goes. The major thing is to just follow the steps and you cannot go wrong. Just follow the steps and you can't go wrong, all right? So let's try and do this following the steps, and let's see where we're going to get to. Of course, you don't want to be too conscious of the kind of expression. You just want to flow with the steps. Now, I'm sure you guys understand the importance of all these things we're doing. We're going to be doing a test on this very soon, so please ensure you are flowing with us. Now we have the first step is increase both the x and y. Look at the way I'm increasing this. Wherever I see y, I'm adding change in y. Wherever I see x, I'm adding change in x. You can see this. But can you see the way I'm using my bracket? Very, very important. You don't want to be just writing things anyhow. You want to make use of your bracket rightly. Look at the way I use my bracket. Very, very important. Now, this step number 1. Anybody can do this question. So please, I just want you to be so confident. I want you to increase in confidence. I don't want you to feel you don't have the ability to do this. Look at what I just did. I increased my x with change in x. I increased my y with change in y. Okay, now what do I want to do next? I want to make change in y the subject of formula. So change in y is equals to 1 minus x plus change in x over 1 plus x plus change in x. Now I want to subtract. Of course, I'm taking this y to the other side, minus y. Now, but don't forget, the next thing is to say since our y is equals to 1 minus x over 1 plus x. So obviously, my change in y will be equals to 1 minus x plus change in x over 1 plus x plus change in x minus 1 minus x over 1 plus x. It's step-by-step process. You cannot go wrong. I always keep saying this. Once you follow the right process, you can't go wrong. Now, what do you want to do next year? We just did a question similar to this. When you have something like this, one of the next things you want to do is confidently take the LCM of both sides. And taking the LCM is basic. You have to just make use of the 2 as the factors. So you can see what we're doing right there. And then you say this goes in this, you'll be left with this. That will be 1 plus, then times 1 minus x plus the x minus, I want to put this in a big bracket. Then I have 1 minus x multiplied by the leftover here, which is 1 plus x plus change in x. You see the way I'm using my bracket very effectively. Very important to make use of right brackets in situations like this. Now, look at what we have here. We have to pay attention in expanding. We need to pay attention to expanding the one on the top. So I will have the y equals to, look at the way I'm going to open this, because these are some of the things that used to bring issues with students, is that students will know all the steps, but when it comes to all these expressions, they start to make mistakes around plus and minus. And can you imagine doing all your best solving all these things and you know everything, and then just a single minus. For instance, let's say you had x and then you were supposed to have x minus x, but you ended up having x plus x, and that spoils the whole thing, and then you get confused in the exam hall because you know what your answer is supposed to be, but you're not getting that answer, obviously because you have made an error with your opening brackets and everything. So let's see how we're going to open this in such a way that there is no issue at all. I actually supposed to put a bracket here. So one of the things I want to do here, I'm going to try and open the numerator. I want to work on the numerator, and let me just see how that goes. So maybe I should even leave this out and just work on the numerator. So look at what I'm going to do. I'm going to say 1 plus x, and I want to open this first. I will have 1 minus x. Minus times x is minus x. Minus times the x is minus the x. So I'm done opening that. Let me see how I'm going to deal with this. Of course, I have my 1 minus x. Let me leave this here and then open this also. This will be 1 plus x plus the x. All right? So that's the first step. Now I want to go on now to open the two. I want to open them together now. So I want to have 1 times 1, that's 1 plus, sorry, not plus now, minus. Because 1 times minus is minus x. 1 times minus the x is minus the x. Then I have x times 1, I have x. X times minus x, I have minus x squared. Then x times minus the hex is minus x the hex. These are places where you have to be very, very careful so you don't make unnecessary mistakes. I have minus, and I want to put this in bracket because you see the way I'm using my bracket. I don't yet want to use, if one of the big issues someone would have made is to just write minus without using this bracket, because this minus is for everything happening here. So if you just don't use this bracket, this minus, you may want to be using it for just this one, and it will give you error. And if you're not careful, you just use the minus for only the one by the close to it. Let's say this was 1, you just going to write minus 1, which would be wrong. All right. Now, look at it now. I want to open what is inside here. That will be 1 times 1, I have 1. 1 times x, I have plus x. 1 times the x, I have the x. Minus x squared. Then I have minus x the hex. Okay. Now we are moving, we are making real progress. Now let me see what we're going to do right here now. Is there anything that can cancel out? Of course, I can see on this side, so I don't have to even waste time bringing it to the other side. I can see that there is a minus x here, there's a plus x here. I can cancel this out. I think that's probably about what can go in that place. So I'm just dealing with, this is just the numerator alone. I'm not yet taking the whole thing. So I have 1 minus the x, sorry, minus change in x, minus x squared, then minus x change in x. Now let me use this minus to open this whole thing. Some people don't understand the importance of what I'm doing. I'm trying to teach you how to express this without making mistakes, because it is very, this is moments where even the best of the best used to make mistakes. And then they end up not getting the appropriate answer. And then it looks all sad because they actually knew what they were supposed to do, but they were not just accurate in their expression. And anyone can make mistake, by the way. Even me can, even I myself, I can. If I'm not careful enough, I would make a mistake in this. This is not all about you knowing what to do. It's about you doing it well. Now, I have been able to open that side. I hope I did not make any mistake. So now I can now try to identify, is there anything that is canceling out? I can see x squared here, and I can see minus x. I can see minus x squared here. I can see x squared here. So this obviously will cancel here. I can see minus x dx. I can see x. So this will obviously cancel right here. I can see 1 here. I can see minus 1 here. This will obviously cancel out. I can see minus x here. I can see plus x here. This will cancel. Can you see why you need to always be confident? See how the complex expression has reduced drastically to just now we're going to be having, now I'm bringing my, don't forget we're just dealing with the numerator alone. So I can write my change in y now is equals to, I'm left with minus dx, and I'm left with minus change in x rather. So I'm left with minus change in x, minus change in x is the same thing as minus 2 change in x, just the same way you do normal algebra. Now over, don't forget there is still a denominator. This denominator now, we have the denominator as 1 plus x plus change in x. And then we have, this looks like a very nice test question. It looks like a question that I know many people may find it difficult to, and it's quite very simple once you do the right thing, right? So look at what we have been able to achieve. Quite simple. We have gotten, now we have done step number 1, step number 2. We now have to do step number 3, which is to divide both sides with change in hex. So we want to do that now. So step number 3 is to divide through with change in x. All right. You know, I told you the very first thing we started with was quite simple and straightforward, but now we're getting into much more. When we get further, there is still much more complex ones than this, and that's why you have to note the basic properly, so that you follow the same step on the complex ones, and you will not get it wrong. So I want to divide through. So I have 2 change in x over 1 plus x plus change in x. Okay, now look at what we have here. I'm not done. I told you in this case now, some people that don't, and you are learning now, I don't want you to make that mistake of trying to write over change in hex. It doesn't really befit you that know what you're doing. So just go on to put this as divided by change in x. So because we are doing it to both sides, we have done to this side, we're doing to this side. And obviously, I don't need to write this again, but of course, if you are in an exam, you should repeat this step and then write what I want to write. But because of time, I would rather just change this to multiplied by 1 over change in x. I'm sure you understand that operation in mathematics. Now we're here, and we can see change in x here. We can see change in x here. I can cancel this. I can cancel this. Obviously, I've not done anything wrong. And obviously, that means I'll be left with minus 2 over 1 plus x plus change in x. Then 1 plus x. These questions come out a lot using first principles. First principle, differentiate this. That's the way they do ask it, because they know that many students will not take their time to learn it. So, and I'm glad you guys are flowing and you're understanding it. So at least if a question like this come out, I'm sure you will not disappoint. So the next thing to do now is the last step, the last but not the least step, is to take the limit of both sides while change in x is tending to 0. So you take for both sides. You don't do anything on one side and don't do it to the other side. That's not mathematics. Mathematics makes sure whatever it does to the left-hand side, it does to the right-hand side. So we take the limit of both sides with change in x tending to 0. So I have minus 2 over 1 plus x plus change in x. And then I have 1 plus x. All right. Now, this, I told you already, transforms to the y over the x. I told you that already. Now, what you have to do here is to fill in your value for wherever you have the x, you want to put in 0. So that will be minus 2 over 1 plus x plus x. Am I right? I think I'm right. This will be minus 2 over 1 plus x all squared. How many of you got this? Those of you that were following me, how many of you got this? You followed this through and you got this same answer. How many of you are there that can say you got this question the same way? And this is the way we build up in mathematics. We don't jump to excellence. We build up on every aspect we're trying to know. So I love the way we have been moving step by step. We don't have to be too fast and we don't have to be too slow either. So you keep building. So we started with okay, good. I like that. We started with good. I like that. I like that. I love that. Please make sure You are flowing. This is the centerpiece of study. So you get the best from this moment you spend uh, for preparation. You get, once you know it very much, you don't miss questions anymore. So please make sure you are really trying your best to understand what we're doing. So if you don't get the first one, you have an opportunity to get the next one. So this is going to be the next one we're going to be solving. Let's take something a bit more, looking more complex, and let me see how you do with this. Let me see how you you get this done. Look at this question now. Y is equals to 1 over square root of x. How do you solve this? All right. So what's your attempt on this? Again, I always say just follow it step by step. You don't have to. You don't have to be. You don't have to be timid when you see questions like this. It possibly looks like it's complex and it's not solvable. It's actually very solvable. So what do you say? How do you solve this? What's your approach to this? Is it difficult? Okay, make an attempt on it if you feel it's not difficult. Uh, okay, somebody, is that person writing the answer? Or is that okay? Let's solve together. I'm not sure that answer was the correct one. Let's solve together and let's see how we go. Step one is what? Increase both variables. Change in y, x plus change in x. You see that? It's the same step. You don't have to move in a different way. Just follow the same step. All right. Now, let's go on now to go on with the step two, which is for you to have the y as the subject of formula. So we have 1 over the square root of x plus the x. Then you make minus y. All right. That's step number two. You go with step by step process, as I always say. Now, don't look at this. Of course, you know that your y is equals to 1 over the square root of x. So what you want to do is to transform y here to 1 over. So we have 1 over the square root of x. All right. So you can see now that we have been able to attain step one and step two. Now the next thing now is for us to try and make our to simplify our expression. All right. So, but before we do that, I'm sure you can see something going on here. We have sorts as both denominator, and this is one of the things that will intimidate some students. But again, you don't have to be intimidated. As I said, just follow the right principle. Whatever we've been doing before, just do the same thing. And what have we been doing before? When we get to stages like this, what do we always do? We take the LCM. So take the LCM. You don't have to be timid at all. So we have the LCM of this, of course, will be what I have here. LCM is quite very easy to get in situations like this. So this is what we have. The LCM is this. Then when you say this goes in this denominator, you'll be left with root x. Root x times 1 will be root x minus root x goes in this. You'll be left with this. That will be root x plus the x. Please pay real attention to what we're doing right now. It's quite very important you pay attention. So I'm sure these are places where some people, I'm sure everybody was able to follow what we did. We went on with just doing the LCM. This is where we arrived at. Now, this is a place where, a junction where someone is a bit confused. And the reason why someone is a bit confused is because the person doesn't know what he or she is supposed to do. And it's quite very simple. When you have situations like this, guys, you want to do something. When I explained this probably last weekend, you want to try and look for something that will simplify the numerator. So if you have, let's say we have root x minus root y. If you multiply both sides, let's say we have this over, let me just write denominator here. If you have something like this, the best way to always tackle this, the best way is to multiply both sides by 1. But this 1 will not be just 1, but we will be having root x plus root y over root x plus root y. We want to transform the form. We want to change the form of this expression, obviously, because this doesn't look like something you can do so much with. So to make it much more easier to solve, you want to do this. This thing we're doing right here is not anything hard. It's just to change the form. So that means if I have this, what I want to do next is this. Look at it. Look at what I'm going to do next. So I have root y minus root x plus dx over root x plus dx. Of course, this is the denominator we have. So if I want to change the form of this, I want to multiply by this, the conjugate of this. That will be root x plus dx over the same thing, because it's obviously just tantamount to me multiplying by 1. But this is, of course, the same thing. So this over this is 1. But I want to use this to change the form. So you can see that, right? Now, what you will see what the effect of this is going to bring. The effect of this is going to bring something very interesting. And let me write the denominator first, because now we are having the multiplication of this and this, the multiplication of this and this. So let me write the denominator first. I'm just going to write the same thing that we have there. So I'm going to be having root x plus dx, then root x. I'm sure you know that. Then multiply by this, obviously, we have root x, then plus root x plus dx. So I just want to repeat that. So I believe everybody can flow with that. In case you are wondering what was written here, it's just this and this. Now, but look at these two tops, the numerator. I want to express it using an algebraic operation. And I've explained this, I believe, last weekend. When you have something like this, something minus something times something plus something, the same thing plus something. This is something in mathematics we call difference of two squares, where you have a square minus b square is equals to a plus b and a minus b. So when you have something that has to do with a plus b and a minus b, which is the exact the exact thing going on here. We have something minus something, something minus something, and something plus something. In this case, that means I can easily express this as this thing square minus this thing square. That's just the principle of difference of two squares. All right. So that means I can write this numerator as root x square minus root x plus dx square. Are you seeing how it's just very important you know this? It makes your work easier when you know all these processes. Now, let me try and rub this place up so you can see it much clearly. I believe you are flowing with us. Now, look at what is going on here now. Because of my principle around sorts and squares, obviously, the 2 here will cancel the square root. The 2 here will cancel the square root also. So can you see how beautiful this is? Now, this very complex expression we once had is already getting simplified. All right. So now we have, when square cancels square root, we're left with, don't forget, we are having dy as dy was the whole thing we were dealing with. So dy now is equals to, the numerator is x minus, then we have, use your bracket. Please don't forget using your bracket well. If you don't, let me show you something that could happen to you if you did not use your bracket well. In a case like this now, you'll be tempted to write, this is what you would have written, x minus x plus dx. This is what you would have written if you don't use your brackets well. You will go on to have just put x by the minus close to x, which will be very wrong. Look at the difference. What I'm dealing with here now is actually x minus dx, which look at the conflict. So this is why you have to use your brackets very properly. Now we have the denominator as what you can see right there. Of course, someone will say we can put it as square, whatever you can put it as. I will just repeat the same thing. So let me just repeat the same thing here. I would have just written DEM, but let me just, for the sake of those that probably need me to write it, let me just write it. And we have this. So we have x plus dx. Good. So this is where we're going to arrive at, obviously. And I don't know if you can see what I'm saying. Can you permit me to just write DEM here? Just telling you that the denominator is what I'm putting there. You understand that already? If you have been flowing with us, you know what I mean by DEM. So the denominator is the same thing there. So look at what's going on here. X minus x, obviously x will cancel x there. Are you seeing what's going on? So this means we are very close to our answer, because we have been able to simplify the whole complex expression now, and we have minus the x now. This is what we are left with, minus change in x rather, minus change in x over this whole denominator, which is this. All right. This is change in y. So this is, we are done with step number 1, step number 2. Now we want to go on with step number 3. What is step number 3? Step number 3 is for us to divide both sides with change in x. So what we want to do now is to divide both sides with change in x. So this is me doing that. I'll be saying divided by change in x. Of course, I told you already, we have done this several times, and you don't need to be writing over. Just put divided by change in x. All right? Doing whatever you're doing to this side, you do it to the both sides. Now, I don't want to write this as divided by again. I want to change it now to times 1 over change in x. And you can see what's going on here. You can see clearly that the change in x can cancel the change in x right here. So what are we left with? We're obviously left with minus 1 as the denominator. Sorry, as the numerator. So we have change in y over change in x being equals to minus 1 over, please permit me to just write them, or do I write it? Okay, let me write it in full, because, let me just write it as denominator, because the next thing, or you know what I mean by that. So the next step now, which is the last step for this question, is for us to take the limit of both sides while the change in x is approaching 0. So we want to do that. I have to write this one in full. So we want to take the limit of both sides of change in y over change in x, and we have our change in x tending to 0. Then I have to do it on both sides. That's the limit of our change in x tending to 0. Then we have minus 1 over all what we have here, x plus change in x, then then root of x. All right. And we have plus root of x plus change in x. Now look at what we have here. The meaning of this is that you have to go on. Oh, I think I did something wrong here. I omitted one. Okay, so let me write it properly. Root of x plus change in x. So what we have to do, the meaning of this is that we have to go on now and fixing our change in x tending to 0. We have to go on to fix that into our expression. All right. So we have all this. I told you already, all this will come on as dy over dx, which is what we're looking for, the differentiation. Then I have x, then I have root x plus 0. Just fix it properly, you will not go wrong. So what I have here obviously is minus 1 over, I have root x, then I have root x, then I also have root x plus root x. You can see the difference. Don't confuse things together. So obviously I have, look at the denominator. Those of you that were following, you understand what was going on. Now change root x times root x is what? Is obviously root x times root x will give you x. I'm sure you know that. So that will be x multiplied by root x plus root x is what? Root x plus root x is 2 root x. I'm sure you all agree with me. You have root x, you have root x. When you add root x plus root x, you get 2 of that. When you multiply root x times root x, it's almost like root x times root x is the same thing as root x squared. That's, of course, let me write it this way. Root x times root x is the same thing as root x times x, which is the same thing as root x squared, which is the same thing as x. So root x times root x is x. These are important operations you should not forget. Some people will work all this to this point, but will not be able to examine these two things. Root x times root x is x. Root x plus root x is 2 root x. And this is getting me closer to the final answer, which is going to be obviously minus 1 over 2x root x, because obviously 2 times x is 2x, and we have right here. You can see the in the very first question, how you progress when you are trying to learn anything. So now this question, now I'm sure some of you, how many of you got this answer? I saw some people drop in and were not perfect. But how many of you got this answer? Of course, those people that drop those answers, they are well appreciated. It's very important you make trials. Even if you made mistake, it doesn't really matter. You can obviously correct yourself. Now that we have done it together, I'm sure you have seen where you probably did some mistakes. Okay, I love what I'm seeing. This same answer while you were solving. How many people are right there? And let you quickly attempt this. This one is not too complex, but let me see. I don't want this to pass by. I want you to attempt this. Those of you that you've been following, you've been working with us, can you attempt this question quickly? Can you attempt this question? Y equals to 1 over x. Okay, I love that. Innocent, I love that response. You got close, but you not get the exact thing. But I'm sure you have been able to investigate your error. Same thing as Peter. Mistake. That's the definition of learning. The ability for you to fail forward. So you made a mistake, but you've corrected yourself. That's really good. So I really believe that everybody right in this class is actually doing the very important thing, solving while we're solving. If you made a mistake, you correct it while we're doing us. So look at this is an attempt. This is another opportunity for you to get very good at using first principle. Of course, we can use the general rule to solve this when we have y being equals to 1 over x. Of course, we know y equals to x raised to power minus 1. This is quite simple. This is not complex at all. The y over the x here will be equals to minus 1 x raised to power minus 2. That will be minus x raised to power minus 2, which is 1. Sorry, there's a minus there. That will be minus 1 over x squared. So this is supposed to be the answer. Whatever you get using first principle, you must get minus 1 over x squared. So, but I would love us to run through using first principle, because as simple as it is using the general principle, it may not be the same thing while using the first principle. So if you are there and you really want to learn this, please put yourself to work quickly. Try and solve this question. All right. If you are done with that one, I would love you to attempt this. So these are the two questions we want to solve quickly: 1 over x, and then also y being equals to root x. So you can, if you're through with 1 over x, you can make use of first principle also solving that of root x. So let's use first principle to solve y being equals to 1 over x. Let's use first principle to solve this. We have y being equals to 1 over x, all right? What do we do while solving this? The first thing, step number 1, is increase both sides. That's y plus change in y equals to 1 over, this is x plus change in x. Step 1. I'm sure you can all do that. Everybody should be able to do this. Now, step 2 is make change in y the subject of formula. So we have change in y being equals to 1 over x plus change in x minus y. All right? At this now, we know that since y is equals to 1 over x, so we would have to transform this expression as this minus 1 over x. Of course, the same thing we have always done is what you have to do here, which is for you to go on and make the subject, sorry, did I write the hex there? Change in y. So I have to go on to find the LCM of these two expressions. So I have to find the LCM of these two things here. That will be x plus change in x and x. So we'll be having x minus x plus change in x. I'm sure that you understand LCM. That's just LCM right there. And we want to have change in y being equals to x minus x. You see the importance of the bracket right there. Minus change in x over x plus change in x. X. I'm sure you can see what's going on there. And if you are following, you will know that this x will cancel this x. So I'm left with, I'm going to be having the change in y being equals to minus change in x over x plus change in x times x. Now, the next step now, which is a very important one, is for us to divide through with change in x. That's step number 3. We want to divide both sides with change in x. So look at it right here. And you know that I always do this. I will now go on to say times 1 over change in x. Of course, looking at this, you know that this will cancel this. So what are we left with? We're obviously going to be left with change in y over change in x is equals to minus 1 over x plus change in x times x. So now we have to go on now to take the limit of both sides as change in x tends to 0. So taking the limit of both sides, we have the limit as change in x is tending to 0 of change in y over change in x. We have to take the limit of both sides. So this is minus 1 over x plus change in x times x. All right. So I told you already that this transforms to the y over the x. Or what we have here is equivalent to the y over the x is equals to, now we have to fix in change in x as 0. That will be minus 1 over x plus 0 times x. That will be what? We have minus 1 over x squared. How many of you got this answer? What was the answer you gave me? I don't even remember. Is it minus 1 over x squared? Okay, I hope that was the answer you all got. How many people got this answer? If you know you used first principle, not the general principle, and you got this question, can you please indicate? You didn't use the general principle, you used first principle, you got the answer, the same answer I'm getting. Can you please indicate this is the answer I got? Okay, I can see people indicating okay, 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 okay. I like that. I love that. I love to see that. Okay, I love to see that. It looks like you guys are being able to use first principle, which is the main goal, to ensure that everybody are so familiar with first principle. So let's solve the last type of question. That's y equals to sort x. Then we'll go into function, and wherever we can stop today, then we'll continue from there tomorrow. Circular functions, then from there we'll be able to deal with exponentials, function, logarithm functions, and then we'll go on to hyperbolic function and the rest. So it's going to be quite interesting. We have a lot to deal with, but all in all, I'm very interested in everybody having the best understanding. That's the purpose of this class. Now, let's try and use the general principle here. For those of you that you probably will even need to know how to use the general principle, all right? So y is equals to, this will be x raised to power 1 over 2. That means y will be equals to 1 over 2, x raised to power 1 over 2 minus 1. This is using the general principle. That will be y equals to 1 over 2, x raised to power minus 1 over 2. I'm sure you're understanding what I'm doing. This is using the general principle. The general did here, then subtract 1 from the power. Y equals to 1 over 2 times x power minus 1 over 2. That means y is equals to, sorry, it's actually supposed to be dy over dx. Please change all these places you are seeing y to dy over dx, not y. This is dy over dx. All these are dy over dx. So this will be 1 over 2. Now we're having times, this will be 1 over x raised to power 1 over 2, which will be what? 1 over 2 times 1 over square root of x, which will be 1 over 2 square root of x. So we already have an idea about what we are going to. This is the answer you should get. If you are correct, this must be your answer. All right, this must be your answer. So we are done with that. Let's now use first principle and see if we're going to arrive at this same answer. Right? Now, the first thing you are going to do is the same thing. Nothing is going to change. Is to increase both sides, increase the x and y, which you can see. That's what I just did. Then the next thing is to make change in y the subject of formula. So I want to make change in y subject of formula. Change in y is equals to x plus change in x minus y. Of course, but y is equals to root of x. So whenever I see y now, I'm putting root of x. I believe we have done too many questions for you to understand the process already. Minus x. Now, what's the next thing now? This is, we have gotten to a place where you have to go on to do this third step. What's the third step? Because in this case now, there's not too much to simplify. You know, we have done step 1, we have done step 2. What are we trying to simplify here? Not so much. So we have to just go on to divide by change in x. So we want to have change in x and everything over change in x. I'm sure you agree with me. That's step number 3. Now, this is now a place where I would love you to remind yourself of what I explained to you. I explained something to you about moments like this. When you have moments like this, you don't have to panic or to be intimidated by the expression. What you have to do is to just look for a way to change the form. And if you look at what we are having there, whenever you have sorts, and it doesn't actually have to be sorts. It could be just a normal expression, but you see that there's a minus here. One of the best things to do is to multiply by the conjugate, which would be, in this case, x plus the x plus, you can see what I'm doing. What I'm doing is obviously just multiplying it by 1, but I will use that to change the form. So this is obviously 1 because this over this is 1. I'm sure you agree with me, right? So what we have now is something that I explained already, the difference of 2 squared. So we have change in y over change in x is equals to, this will now be obviously the change in x plus the x all square minus all square. This is difference of 2 square. I think I explained that already before. And this will be over Now we multiply all these things together. And this would be change in x multiplied by x plus change in x plus change in x. All right. And this obviously is a good point for us to, we can simplify our numerator by cancelling the square root. Of course, that's something you can do easily there. So we have x plus the x minus x, then over change in x plus the x. This is a very great test question, by the way. I'm sure you can see the reason why something like this could be asked. So minus x cancels x. So what are we left with? We are left with change in y over change in x is equals to what? Change in x is what is left there over change in x. Then we have x plus change in x plus root x. So what do we do? Sorry, why am I doing the y over? Okay, I've done that already. Okay. So, okay. So look at what we have right here. The dx here will cancel the dx here. So obviously we are left with 1 over x plus change in x plus root x. So looking at what we have right here, I'm sure you know that the next step is for us to fill in the values for x, sorry, for changing x as 0 while taking the limit of both sides. So taking the limit of both sides, as changing x is turning to 0, you'll be having sorry, this is 1 over x plus change in x plus change in x plus root x. So you have to, of course, know that this will all transform to the y over the x. And then this will be 1 over, we have x plus 0 x. Of course, that will be 1 over root x plus root x. Root x plus root x will obviously be 1 over 2 root x. So can you see how great it is for you to understand the first principle? It's quite very simple. These are the kind of things you should expect in an exam hall, and you should be very versatile in solving this. Now, I want to give you something you will do on your own right here, and then right here, I want you to solve it. We don't necessarily have to. Just let me see you perfect your knowledge on this. So now you have y equals to 2x cubed minus 5x squared plus 3x minus 4. Can you make use of first principle? Can you quickly do this? Make use of first principle solving this question. Can you quickly attempt that? First principle, make use of first principle solving this question. And let's see how you're going to do this. Use first principle. Using first principle, can you do this quickly? I think we did not solve any type that looks like this. Using first principle, I'm not sure this person that wrote this answer used first principle. I believe this person used the general principle because you should not be that fast. I understand using the general principle, you are going to get a very you're going to get the answer very quickly. Of course, you can easily get the answer using general principle. The y over the x here will be equals to 6x squared minus 10x plus 3. I know that. But can you use first principle to arrive at this answer? And I get great responses quickly using first principle. If you know you have used first principle, let me know. Let me know. Indicate using first principle. It's quite long, and that's why I want us to try it out so that you don't see something like this and it looks like we have solved other expression. Use first principle. It's quite long. It's not something you're going to arrive at in a short while. Using first principle. Using first principle. Can you do that quickly? Using first principle, can you arrive at the answer to this? Using first principle. It's quite something you would need to be patient and very. It looks very simple, obviously using the general rule. But when you apply first principle, you know this is going to be a bit long. Look at it; it's going to have quite a number of increment because we have different x's. We're going to be having x plus the x cube, and we're going to have minus then x plus the x square. And you see that why I said it's going to be long. Then we have plus 3, then x plus the x, then minus 4. Can you see exactly the whole process? Okay, so I don't know. Look at what we have right here. I'm sure you understand why I'm saying, okay, these answers you people are giving me, is it using the general principle or did you use first principle? That's very important because using the general principle, I know you can get this in probably like 2 seconds. But using first principle, are you able to prosecute this using first principle? It's quite very long. And believe me, if I'm going to ask you a question on first principle, this is the kind of questions I want to ask you because it's very testy. So what are you guys saying? How many people is there anybody that used first principle to get this answer? Anybody there? Okay, you use first principle. Okay, that's good. That's good. I give you the thumbs up. Is there anybody here that has used first principle? First principle. Okay, so we have y plus the x, the y equals to, this will be 2, and we're going to have x cube plus, I just want to write the answers, we don't have to waste time here, 3x squared, because I know some people are there and they probably will have issues with this. And there's no point in having issue with something this simple. Sorry, square, not cube. Then we have plus the hex. Sorry, changing the hex. This is quite very long. Can you see how lengthy this is? So that's just for the first part. It's quite simple, but it's still very long. So you'll be having x squared plus 2 the hex plus the x all square plus, then the last one now. Okay, someone is still solving. We have 3x, let me open this, plus the hex, then minus 4. Are you seeing the whole complexity that this thing is bringing? So is that's the major thing here, is that it's quite long. It's quite very long. So you have to solve it very patiently. Now this is just the I've not made the y solvator formula. So look at what will happen when I make the change the y solvator formula. I want to try and open this quickly so that at least we can lessen some of this. So this is kind of, I think I would love to bring something like this out. It's quite very nice. It's testing. Minus 5x squared minus 10 the hex. I'm hoping I'm not doing anything wrong, because at this point I'm also trying to be very I'm also trying to be very fast. So where am I, by the way? I think I've done for this. I think I have to do for this last one, the x squared, then plus 3x, then plus changing x minus 4, then I will now have minus y. You know, I am making the y, so changing y solvator formula. So now I can change y to whatever y was before. What was y before? I think y was x cubed minus 5x squared plus 3x minus 4. And you have to use your bracket here. This question, very simple, but I can assure you, if you're not very careful, your signs will really, really imagine you just wrote y and you just wrote it straight up. I'm sure you can see that the number of errors that has happened already, because you wrote minus y and you just wrote y without using the bracket. So because I don't want to write so much, that's why I want to do the next step without having to. So I just remove this by minus. I'll turn this to plus, this will turn to minus, this will turn to plus. That's me using minus to minus to penalize everything. So you see I'm still correct, right? So you can see how very testy this is. So this is kind of question I think you people should be expecting. I would love to see you crack this up. It's quite very interesting. So changing y will be what? Even the whole expression itself is quite hectic to look at. Okay, somebody is pointing one error I did. Where's the error? 3 what? Thank you. Can you see? You see how easy that is? 3 is supposed to be here. 3 is supposed to be here. Exactly. So I'm not going to obviously go on. You know the principles already. What I'm supposed to do next, which I would love to even do at this point, would just be to say divide both sides by the hex. So like at least I can cancel out all the change in hex. So I'll be having what's the first thing here? I'll be having 2x. Did I have 2x cubed here? Okay, 2x, I believe 2x cubed happened here. So this will cancel this. Can you see that? Is there anything that is canceling again? This also is canceling this. This also is canceling this. Is that not interesting? This also is canceling this. Can you see how beautiful this is? So we're almost done with all our expression. Everything has almost cancelled out. So I don't know, is there any other thing that can cancel out here? This is 5, the x squared. Oh, I wish this was 5. Okay, this is even 5, not 5 hex. So let's try and just divide through with change in x. So I'll be having change, of course, this will be 6x cubed, or change in x, that will be 6x cubed, 6x squared rather, left here. This one will be left with 6x and just one change in x because one would have gone. This will be left with 2, and then we'll be left with 2 of change in x because one would have gone also. This one will be left with minus 10. I hope I don't get this wrong because I wasn't very patient in doing this. So change in x will be left here. Is there any other thing left? Then there is a plus 3 left here. All right. So I hope I have not done anything wrong. Can anybody confirm that? Am I on point? It looks like where I wrote 10 here, looks like I'm supposed to be having 10x. Looks like I made an error there. 6x dx, 2 dx square, minus 10. I believe something happened in this minus 10. Where is this coming from? Yeah, but this is where do we, this is okay, minus 10. Okay, can you see what happened here? The way I wrote 2 change in x is supposed to be 2 because this is 2 times x times dx. This is supposed to be 2x. So this is supposed to be minus 10x. So this will be minus 10x. All right. So I believe all things being equal, this is quite still good. So at this point now, all I have to do is take the limit of both sides, and you know what that will give you. This side will turn to the y over the x. I'm sure you know that. And this one, I want to put in wherever I see the x, I want to put in 0. I'll be left with 6x squared plus 6x times 0 will be 0. 2x, this one will be 0. So will be minus 10x. Minus 5 times 0, this will be minus 0. This will turn to 3. So the answer is giving us 6x squared minus 10x plus 3. Wow. Isn't this nice? So can you see how easy but quite tedious this is? So this is using first principle. This is how we solve it. I don't know how many of you were able to flow with us. I believe we should have a good number of people that really understand what we're doing. So guys, thank you. At this point, we will have to be quitting the class. Tomorrow, we'll be getting deeper into calculus. There is so much to learn. There's so much to learn, but you know, when we come to our classes like this, we are very interested in step-by-step process. We don't want to be too hasty, so that everyone, we're not just carrying the brilliant people, the intelligent people along. Everyone, whoever is having, even if you just started learning first principle, you can still flow with us. So this is really great. This is quite really great. I believe I've been able to make you understand this much better. I want you to ensure you put in your best also to ensure that during the exam time, this all will turn out to exam success, and all this effort will not be in vain. Someone is asking for a take-home assignment. Oh, okay. Okay, let me give you something that will lead us to our work for tomorrow. That will be something around, I would love if you much better tomorrow. Can you attempt doing these two things to cos x and y being equals to sine x? Can you try and use first principle to differentiate this? All right, that's assignment you take home. Quite very nice. So try and attempt that, and then we'll see tomorrow. I'll give you the solution to it tomorrow. So guys, thank you very much for joining. I hope to see you tomorrow. Yourself. Bye-bye. Good night.